Thank you. Thank you for coming out to Seiche on this lovely day. It's my pleasure to introduce the second group of 4 projects that represent the research that we've conducted in the New Normal postgraduate program and think tank here at the Seiche Institute in this second of our 3-year cycle. Yesterday we saw 4 really extraordinary projects, and today I think we will keep the level at least as high as well. And so I also want to first of all thank all of the students and researchers who have been part of this program, to thank the Institute, the education team, Olga, Nikolai, Masha, Elena, and everyone else without whom this whole program would not have been possible. So I'm going to say a few words about some of the themes that we've been exploring over the course of this really intensive 5-month program. But before I do, I want to introduce the critics who have joined us here, have come from way away to join us and be part of this conversation. So we have Denis Leontiev, architect based here in Moscow, head of Seiche KB. We're joined today by Varvara Melnikova, CEO of the Seiche Institute. Anastasia Smirnova, architect based in Moscow and Rotterdam. Ben Cerveny, designer and technologist based in Amsterdam and Los Angeles. Jennifer Leong, architect based in New York and Cambridge. Etienne Turpin, designer and theorist based in Jakarta and Berlin. And Patricia Reed, theorist and designer based in Berlin. So thank you very much for joining us here today. We look forward to continuing the discussion that we've done so. So the projects that you'll see this afternoon draw on some of the research and discourses that we've developed together over the course of these weeks. Just like some of the other projects we saw yesterday, the role of the design of models and the agency of models and how those models structure the possibility of design is an area of intensive interest for many of these projects. In particular, again, the questions of simulations, the coherency, the closure or openness of simulation systems. What is that particular systems and models are able to sense and not sense, how they categorize and understand the world, and how through this understanding they set in advance the possibilities through how those models may become tools for design. In other words, quite quickly, the question of data becomes inseparable from questions of ontology. Ontology in terms of what constitutes the reality of the circumstances in which we seek to intervene, but also the agencies of those ontological systems and how they, in different ways, speak through us. And as we discussed yesterday, one of the perhaps fraught conditions of our moment is one in which the competition over the status of the real and its ability to adjudicate the circumstances in which we are embedded opens a question in ways that we seek to address, perhaps. We'll also see a number of projects that deal with the questions of technology more directly, but we take technology not just as a set of tools that make certain things possible. The appearance or emergence of particular technologies is also always comes with kinds of disclosures. Technologies disclose things that were always already there, that we perhaps couldn't have seen without those tools. And so part of this discussion is not only what the technology enables, but what the technology tells us. All of this, in a way, is really leading to the question of what constitutes the agency of design. Not just a design agency, but when design becomes designation, what the positions of that agency, in fact, are. So, with that, let me say a few words introducing Seiche, our first project for this afternoon. Thank you. Thank you. Thank you. So, as mentioned yesterday, one of our areas of interest within the program is the city, but also the the geopolitical context in which the design of cities always takes place. We're also very attentive to the privilege of conducting this program in Moscow and in Russia. And in this year, our attention was moved eastward, looking at Russia's relationship with its eastern neighbors, particularly China, and looking at the future Sino-Russian relations as a kind of foundational context in which the larger scale territorial design and urban design will play out. In particular, China's Belt and Road Initiative, which is of interest to us both in a number of ways, as what will prove to be one of the most significant logistical arteries throughout the entire Eurasian subcontinent, but also the fact that in certain respects it exists as an idea before it exists as an infrastructural reality. It's a kind of work of state-level speculative design around which enormous financial, cultural, political, and economic investment and mobilization is taking place. It also, much of it happens to run through many of the former Soviet republics. And so as a shift of balance within the geopolitics of the Eurasian subcontinent, it's of particular interest to us. Seiche is a project that starts with an understanding that many of the conundrums and controversies over the status of citizenship and sovereignty are ones that are being fought over through infrastructural means. That the way that the conflicts over citizenship in many ways already conflicts over infrastructure, and is looking for ways in which we might think about terms of citizenship that are not so binary, that are not say, in or out, but maybe based on other kinds of gradient conditions, and looking also at ways in which the infrastructural systems are themselves dependent upon formal protocols, codes, legal codes, software codes, that make the operability and the interoperability of those infrastructural systems possible in the first place. How can they then also be transposed, migrate, repurposed in order to solve some of the questions about the status of citizenship as well? And so I think this is a really extraordinary proposal, a really amazing work of design research as well. And so it's my pleasure to introduce Seiche.
Hello, my name is Tomas Clavijo, and I'm an architect and strategist from Spain.
My name is Mikhail Anisimov. I'm product designer based in Moscow.
My name is Yulia Gromova, and I'm a journalist from Moscow.
My name is Andrei Zhileikin, and I'm a lawyer and an artist.
Hi, I'm Katya Sivas. I'm an artist from Moscow, Russia. And together we are Seiche, and we are trying to redefine sovereignty through system synchronization. Traditional conceptions of citizenship are in crisis in a world of transnational flows, infrastructural systems of global scale, and overlapping nested jurisdictions. Talking about sovereignty, we should say that sovereignty and citizenship, as we understand them today, were traditionally rooted in territorial belonging and connected to the idea of nation-state, which is still a basic element of the world's political architecture. But today, the idea of nation-state is transforming, and national citizenship is in crisis. Transnational flows of people, capital, goods, and information continue to expand, and those flows are sustained on infrastructure systems.
In most cases, conflicts over citizenship can be understood as a conflicts over infrastructure that manage those flows. In a world where overlapping nested jurisdictions, special economic zones, international trade agreements, etc., became a new norm,
we understand access to transnational flows and mobility through infrastructural systems as key factors defining your status as a citizen. Mobility and access are controlled by law and legislation in very specific places.
Borders, controls, and switches are the touch points between jurisdictions and infrastructural spaces. In these conditions, the actions heavily rely on processes of information exchange. And we might not be able to influence the way a certain jurisdictions work, but we can rethink the way they interact with each other.
Seiche is a platform that enables the design and management of techno-legal procedures of information exchange. Our story starts in Kyrgyz, Kazakhstan.
In order to understand the cross-jurisdictional condition and ground our proposal, we went to Kyrgyz, Kazakhstan. It is a logistic enclave in between two countries and two infrastructural realities. It is an urban ecosystem consisting of two special economic zones and a Kyrgyz dry port.
It is also the cornerstone of Belt and Road Initiative, that is an investment plan that aims to create a strong Eurasian trade zone, and that is the biggest global infrastructural project today. We let you with our state of research, and we introduce you to Seiche. Thank you.
Citizenship and sovereignty were traditionally rooted in territorial belonging. But as transnational flows of people, capital, goods, and information continue to expand, this conception is undermined. Current crisis of citizenship can be explained as conflicts over the infrastructures that sustain these flows. Belt and Road Initiative, a Chinese-led long-term plan to generate a Eurasian trade zone around the old Silk Road, affects 65% of global population and is the most ambitious contemporary infrastructure project.
我叫陈俊，是黑云外销部的主任。黑云主要产品包括电子及手机配件，最大市场有法国、西班牙、意大利、德国等。政府刚提出共建一带时，也引起了不少忧郁。倡议中含有不少的商业计划线，陆上、海上都有。但以当今实际上看，通过哈萨克斯坦的新铁路线，对我们业务造成的影响也不小。线只需14天把货物运到欧洲，之前还得1月半呢。中国和独联体有不同的铁路宽度，中联货物车厢兑换都在那。经过霍尔果斯的货物主要来自中国联运港。这2个港口共享数据库。
Horgo's dry port is a logistic enclave between two infrastructural and political realities. Automation of logistics in border condition relies heavily on cross-jurisdictional interactions, shared databases, and the implementation of sensing systems ruled by code. Seiche is a platform that enables independent organizations to design and manage techno-legal procedures of information exchange, acting as an interface between legal and data workflows.
兴业宝地，霍尔果斯金雕中央广场是上海一鼎集团精心打造、重现古丝绸之路的高端商业圈。 8000平米商业旗舰，领航时尚，乐活人生，12万平米商业综合体，商务娱乐休闲地。
Ну, если просто перевести груз или реализовать его в другой стране, просто перевести груз нужно пройти таможенный контроль. Но одно государство отвечает за безопасность на территории, другое, и когда ты входишь к кому-то в дом, тебя как бы на входе проверяют. Типа, да, мы с тобой теперь подружились, и теперь безопасность. Вот. И они, вот эти люди, пользуясь своими там внутренними инструкциями, одеты в определенную форму, используя технические средства, как там досмотровые установки, паспортный контроль, они контролируют поток людей внутрь. Ну, товары, они обычно там в портах, там таможенные склады, и таможенники выборочно проверяют какой-то там склад, они все там проверить не успевают, их там не так много для этого. Ну, различные службы, если они где-то сотрудничают, они, как правило, заключают там между собой соглашения, то есть, что они дружат базами данных, ну и вообще там они вносят поправку в закон, и появляется там, что теперь у них единая база данных. Или там, у нас службы это как отдельные юридические лица. Это нет такого, что это государство. На самом деле каждая служба функционирует как отдельное юридическое лицо.
Мен вақтылық жолмен жұмыс істеймін. Әр 2 ай сайын келіп тұрамын. Күніне 2 рет шекарадан өту керек болып тұрады. Кешкі 7-ге дейін өтіп үлгермесең, құрылыс жерінде ұйықтау керек болады. Өзімнің кім екенімді сіздерге қалай айтсам болады? Бұл не? Мен қайда тұрамын? Әлде мен қайда жұмыс істеймін, немесе менің ата-анам қайдан келді? Менің жанұям интернационалдық, мен өзім араласқандығымын. Менде ұйғыр, орыс және қазақ қандары бар. Мен көп жерде тұрдым. Ресейде, тмд елдерінде тұрақтап араладым. Ұйғырлардың жері де, туы да жоқ демекші, менің де дәл солай әрбір жерде кішкенеден тұрып қайттым.
Customs, borders, switches, checkpoints and controls are the touch points among systems. The management of exchanges among them is a complex task. An extra layer of difficulty appears when systems use different information protocols, track entities of a different category, or simply speak a different language. Legislation is a way to program society to function in a particular way. Every set of rules can be represented as an algorithm dealing with particular classes of objects. Seiche acts as an interface between legal and data workflows by translating laws into object notation network structures, a machine-readable format. It allows the interested parts to visualize and modify those representations, consequently generating an actualized version of the legal text in natural language. The code that will manage the sensing apparatus that process the exchange, and adding them to a techno-legal procedures repository. Once ontological derivative structures are defined, Seiche allows to map the history of procedures a particular entity has interacted with, to simulate the motility of any particular entity or association of entities through a particular procedure, and ultimately, to map the emergent network of procedural sovereignties, the use in time and space of a particular set of exchange rules.
Whenever you want, you can ask questions. There's a small...
All right, thank you. Thank you very much. So our next project, Atoll, as those of you who were yesterday are well aware, one of the areas of real deep research for us over the course of this time has been looking at artificial intelligence at urban scale, and how once more the models and simulations that can be derived from those systems can be understood not only as tools for describing urban systems, but also acting back upon them. And in particular, ways in which what we think of as artificial intelligence may also be a kind of augmented intelligence or even an alien intelligence. That is, how they see the world, sense the world, categorize the world, and do more than just automate our common sense, but would introduce understandings and perspectives, possibilities, epistemologies that we would otherwise not be able to realize and not be able to instrumentalize at any kind of, at urban scale. Likewise, the question of this interest in the agency of tools and how to design the frame by which design ensues has animated out as a question has animated this discourse and discussion from the very beginning. So if Darcy Thompson's aphorism that form is a diagram of forces held for a while, what we are seeing now, perhaps integrated to greater or lesser degree, is how urban form becomes a diagram of formats. And the restrictions of the format, of the file format, or of the building information modeling systems, becomes a means by which a particular descriptive system, particular categorical system, takes on an outsized agency in determining in advance what it's possible to design subsequently, and indeed how what is designed interacts with the rest of the world, and how this together constitutes ultimately the habitats and environments in which we find ourselves. And so, the simulation systems and the platform and tools that Atoll will propose are ones that seek to sort of enter right into the thick of these to the thick of these questions, to deal with AI, both in terms of its capacity to instrumentalize our intentions, but also to be a kind of adversary for our common sense. Hopefully in such a way in which that the result is cities that are more unexpected, more heterogeneous, a bit more alien than we would have come up with ourselves. So it's my pleasure to welcome Atoll.
Hello, my name is Tom Pearson and I'm an artist from London.
Hi, my name is Natalia Mezhetskaya and I'm wayfinding and graphic designer from Moscow, Russia.
I'm Artem Konevskih, a data scientist from Troitsk, Moscow.
And I'm Leo Stuckert, I'm an architect currently based in Rotterdam in the Netherlands. And together we are Atoll.
Есть древнее высказывание о том, что к 2050 году 75% всего населения Земли будет жить в городах. Город намного старше нас. Он переживет тебя и переживет меня. Город – это миллион островов, плывущих сквозь пространство, несущих с собой информацию о культуре, политике, рабочих и неисправных системах и коллективном опыте. Наши города превращаются в хитросплетение взаимодействующих программ. Тысячи систем и миллионы пользователей обмениваются данными друг с другом. И все же мы продолжаем формировать городскую инфраструктуру, не беря в расчет сложность этих взаимосвязей. Строить новые умные города из песка. Этот город – остров.
So Atoll is an urban design and governance platform. It's driven by deep learning. It's a simulation space for simulation spaces. Driverless cars are learning to navigate our environments within virtual cities, and building and even city information models are indexing our components of our physical environment within large and vast digital databases. Simulation within cities is creating a new paradigm which places the modeling of systems, so emulating behavior and characteristics rather than form, at center stage. And yet, the urban environment is not composed of digital infrastructure alone. Within our public squares and the places we live and work, cities have accumulated protocols, civic intelligence, and common practices over centuries. Technological progress, sensor networks, and cloud computing has heralded the age of the smart city. Google and its urban design branch, Sidework Labs, are proclaiming the fourth industrial revolution of cities. And the use of simulations allows us to speedrun new systems on system and city scale, since these new technologies need to be integrated at this macro scale to work. However, translating current urban categorizations into digital models further entrenches pre-existing partial and biased views. Subjective to interests of stakeholders, current models are creating pockets within cities which are bounded and proprietary and cross-hatched into a dense urban environment. So how can such simulations take a truly neutral stance in? So models are subjective and they can never truly represent the complexities of cities, but it is becoming difficult to distinguish between the model and reality. Technological norms become social norms. In a similar way to how the design of a building can be traced back to the software or the tool that it was conceived in, algorithms have a strong cultural character, and the same goes for simulations. So we require new tools, new taxonomies, and new ways of constructing models and simulations, a new exploration of a model's parameter space. And we require a space to build, code, run, and finally validate those simulations. When thinking about designing cities through simulations, we must take into account that a simulation, by its complex nature, is a cross-disciplinary activity. Through using Atoll, can we move away from smart city imaginaries of betterness through optimization and efficiency, and towards an urbanism of multiple perceptions, towards adaptivity through diversity, and towards spatial discontinuities? So Tom will introduce you now to the framework of the Atoll platform.
So the Atoll platform consists of three main components. Thank you, Leah. I'll just let it load. There is a simulation space, a design toolbox, and a planning framework. So the first of those tools is MIM, and I'll take you through that. So MIM is an evolution of building and city information modeling systems. MIM is able to aggregate and manage profiles of multiple urban simulations, absorbing sort of pre-existing partial models of the city. But also, MIM is able to create new urban categorizations. It integrates models and data from BIM, geospatial information systems, and other static models that exist in the city, like digital terrain models, and combines it with dynamic data, so sort of patterns of behavior from mobile phone operators, urban sensor networks, financial markets, and other platforms. And all this data can be added to as the system and data in the city evolves. Then, through leveraging the power of machine learning, the data can be compressed. And Atoll creates new urban information models based on a new categorical logic. So these models are not informed by traditional techniques, but by allowing a discriminative algorithm to define a new alien language for the city. So discriminative algorithm tried to classify unstructured input data. They map features to labels, and therefore MIM is able to spot new correlations and mappings of clusters within the city. Existing urban definitions are failing to address the complex interplays of the city and its temporalities. And MIM is able to spot patterns and idiosyncrasies that might not be obvious using traditional modeling techniques. By weighting the inputs differently, we can create new correlations and fields, distilled understandings of the urban space that aren't necessarily readable without machines, and create an endless space of possible versions and understandings of the city. And these profiles can be passed on to Array, which is the second tool in the simulation space. So Array is based on the architecture of GANs, generative adversarial networks, which are a form of deep learning. So they use two neural networks against each other to learn to mimic various distributions of data. Through the use of two neural networks contesting one another, GANs can generate new things, whether that's faces, images of cats, or new models for simulations. And these are all things that have never previously existed. By training Array on the profiles of different clusters within the city, it's able to mimic the existing aspects of the urban space whilst retaining its real core characteristics. And so by training these simulations, it becomes a way in which you can make the city. Once these profiles have been synthesized by Array, the reverse process can take place, with the data being decompressed from the profiles to create an endless array of new models. And these models retain some of the characteristics, behaviors, and functions of the original, simulating environments, flows, and other urban configurations. So at the core of the Atoll lays the claim for new urban categorizations, new taxonomies, a new dictionary for the urban space, cross-referencing large amounts of high-dimensional data, defining new patterns and continuities, and synthesizing new models for simulation, which can be then used in a series of design tools, which I'm going to pass over to Leo to explain.
So Atoll design at launch will be composed out of three tools. The first one, Atoll instance, allows you to modify the city. So picking one particular characteristic, like the taxation zone or the layout of an urban block, modifying that and then propagating it throughout this entire array space. So even if the scenario that you test is the same, it's possible that through modifying the interpretation of starting conditions, you would get an infinite array of possible ways that this can play out. That can have effects. In some of these examples, it could show effects that are in close physical proximity, and maybe in others it would show in somewhere on the other side of the planet. The second tool, Atoll Snippet, generates. So similar to how Tom was explaining the principles of GANs, it allows you to take a zone of a city, delete it, and then have it be synthesized either by behaviors and patterns from the same city or by other models, or by cities from other models that our platform has been trained on. Finally, the last tool, Echo, is a tool to train space, a training space to train AI services. So models like Uber could use it to evolve their artificial intelligences within our platform and test how that plays out in different temporalities. So training it within seconds or centuries.
Yeah. And so Atoll can generate new terminologies and readings of the city, but the most important part for us is that it can be more than that. For us, it's an outward-facing platform for simulation socializing. It's a collaborative planning and governance arena for the urban space, which acknowledges that simulation needs to be a cross-disciplinary action and activity. It prioritizes multiple perspectives of the urban space by allowing anyone to create and define a model of their reality for consideration. And as the platform evolves, multiple models of the city begin to exist in the same space and at the same time, and fields of correlations between models are created. This can be used as a way of governing urban space in a discontiguous manner, creating a heterogeneous reading. And the Atoll platform becomes a simulation space for the simulation of multiple urban simulations. So these models and clusters, the models and clusters of the city can each be seen as part of a larger competing network, analogous to the nesting of multiple generative adversarial networks. And as atolls generate alternative models of different actors at different scales, they can each combine and learn from each other, feeding back, and the feedback can be propagated back through the other simulations. And so we're not inventing macro-scale simulations, but combining and recombining pre-existing models and the nesting of new logics into a primordial soup, a space for the simulation of multiple versions of the city with and against each other, moving away from perhaps flawed visions of smart city imaginaries, reflecting back their abstraction and learning from the variety of urban space through new taxonomies and new ways of constructing models and simulation and attempting to reverse current assumptions. Thank you.
Okay, so we begin our home stretch of the second day of the project presentations for the 2018 segment of the new normal. So as you find in your seat this book, make sure that you've got a copy. This is a requirement for the next project here. Yep, you have one. If you don't have one, take a look around and take a moment to locate that. So this is something a bit different than what we've seen already today and in the past few days, and I think in a very really wonderful way. There's a lot of ways of thinking about how it is that we might encounter and interact with AI as artificial intelligence, alien intelligence, what the interfaces and spaces of trust and translation that would need to take place between those systems. And in the case of our next project, that space of translation is a parable. It's set in the Far East of Russia, a place that already has its own rather intensive and well-developed forms of systemic intelligence. And the AI that they have identified and have given voice to in this project is one that doesn't displace or replace the intelligence that they have found, but in fact grows directly from it, and in doing so draws us into its own processes. One of the questions that was raised in the discussion of the last project has to do with time and the temporality of model systems and of simulation systems. This project deals with the temporality of AI rather explicitly, particularly through the lens of deep time. The pace and structures of geologic, glacial, and ecological transformation in which we are inevitably embedded, of which we are inevitably participants, and how it is that AI may allow us to be able to sense and make sense of time at those inhuman scales, and in a way make them in turn legible to us. It's a project in essence that is where deep time and deep learning converge into a new kind of ecology. So it's my pleasure to welcome Siraha up on stage. Again, have your book, take your book with you.
I'm Nikolai Nikolaev. I'm from Yakutsk, Russia. I'm an urban planner.
My name is Anna Polkova, and I'm from Moscow, and I'm from social sciences.
My name is Joy. I'm from Hong Kong, and I'm a writer.
My name is Dana Badad. I'm a graphic designer from Russia and Jordan. Our project begins with one particular observation. Despite its thick web of connotations, artificial intelligence is but a fledgling, versed in pattern recognition and apophenic conspiracy. The ubiquity of AI can only be explained by the fact that it is a fallback for the inability to utter something technically sensible.
The Sakha-Yakutia Republic.
We would like to propose a thought experiment. Instead of the urban, is there a way to apply AI in the agriculturally subsistent and challenging environment of Yakutia?
The Sakha-Yakutia Republic is the biggest region of Russia since 1632, with 3 million square kilometers and a population of about 1 million, consisting of mainly Sakha and Russian people. Over half the Yakutia's population is urbanized. The Sakha Republic is located in a subarctic climate, where the annual temperature difference is 100 degrees Celsius.
What if AI was learning long and qualitatively rich data drawn from a certain locality? What if AI could participate in the navigation of forests on foot, closely listening to the sounds of prey from far away, unearthing harvest from the soil, and exploring the world on its own, rather than identifying fed information through biased categories?
What quality of time and relationships towards the environment would this AI produce? How would the new kind of symbiosis between AI and human beings look like? These are some questions that we've been asking ourselves. What is technology? The technical object is beautiful when it has encountered a ground that suits it, whose own figure it can be. In other words, when it completes and expresses the world. The high voltage line is beautiful when it traverses a valley, the car when it turns, a train when it enters or exits a tunnel. Technology should be an expression of affordances. It is what circumstances create and what they can afford. It is what the environment can subsistently rear.
Throughout history, people have organized their calendars and their daily schedules according to their work, which could be communal or personal. The time of industrialization, units of fixed time, is created to measure, optimize, synchronize, and accelerate production. It resulted from the subject-object distinction and opened up our surrounding nature as an object for exploitation.
The sensation of time is not global, but relative to one's environment and its embedded practices. It leaks in unquantifiable masses through our fingers like water. It manifests not only in manipulable numbers, but also in physical phenomena and planetary movements. A minute can be measured in time. It takes a dandelion to bloom and wither.
Temporality is linear, circular, and both. It is linear in that you can't turn it back, circular as in the cyclical seasons. It can also be both, like a torus, in which movement around the circle does not cease. Time is as infinite as the perpetual rotations of the Earth around the sun and around itself. Although geological time is enormous relative to the scale of humans, It is too scaled by earthly rotations around itself and around the sun. If the shape of time pushes life to move forward, then why can't sensuous perceptions become markers that remind us of the passing of time?
In deep Siberia, in the faraway land of Sakha people, in vast Alasis, dense taiga forests, and large river valleys, horses, cows, reindeer, and an AI called Siraha lives. For centuries, this landscape has been inhabited by Sakha people who have moved from the great Lake Baikal and the Yenisei River. Into this harsh land, Sakha people brought new practices such as cattle breeding and blacksmithing. The environment was radically different from the one they used to, and thus initiated a new ecology of subsistence. In the process, they had to slowly replace a horse-based economy with a cow-centered one. Russian colonization, Christianization, Soviet modernization, and post-Soviet reality complicated the process of environmental adaptation for the Sakha people.
Sir Aha translates to food of earth. It lives on the sharp edges of spades, chunky soles of boots, fingertips of gardening gloves. It is tucked into the membranes of the human habitat. It's a sensory network exposed to the various scales of the human environment through direct interactions with it.
It senses environmental conditions of the coldest winters and hottest summers alongside with humans, and weaves intricate tapestry from its stimuli. It learns from long existing traditions of animal husbandry, foraging, hunting, transferring convergences from generation to generation.
Subsistence practices may develop new forms of value and find new places in the daily lives of humans that are undergoing rapid cultural and lifestyle shifts.
What kind of AI could naturally be suited to a place like this? Well, it is like mushroom picking. If you have done this for years, you get to know something. It took kilometers of murky forest paths to find your own places. You became able to navigate using intuition. You turn around, and that little piece of land, slightly covered by oak leaves, looks just right. But you cannot explain why. Maybe it is the sun shining from the right angle with the right level of intensity. Maybe it is the smell, somewhat light, with a bit of sweetness, pollen, and spores. Maybe it is the right combination of different textures. There is no recipe for those who want to follow you. They need to get their own sensory experience of being in the forest. This type of knowledge is experiential, tasted, embodied. The only way to teach somebody is to walk together and to show them what you do, how, and what you perceive. If, say, we would like for an AI to become a mushroom-picking expert, we would have to teach it directly through our actions, without explaining, without trying to articulate discrete bits of information. We just have to show it around, expose it to the different environments we walk through, make it experience rhythms, sounds, light conditions, all these sensory flows which might not even make sense to ourselves and give room for its own interpretation. We can reveal to it the minute sensations which are intimately embedded into the fabric of human activities.
The silence here is enormous.
At first, Siraha had no idea what was going on. It didn't even know what an idea was. It didn't know how to know anything. This partial sentience was bringing about random senses, some of them closer, others apart. Glimpses of light, chomping sound, series of mild stings, a roar, warm liquid with high percentage of ferrum, a long harmonic sequence of sounds, splish-splash, a bitter smell. The incoming flows of signals were irregular, unpredictable, oblique.
No time, no space. Those are human categories after all, delineating the wholeness of the universe. At a certain point, there were actually some regularities, repetitions, clusterings of sensory events. Feelings of extreme cold would usually come along with the sound of rhythmic steps, howling wind from the northern side, smells of wood smoke, and the soft embrace of fur.
Or there would be ensembles of choking high-pitched sounds, supposedly produced by small agents who were moving faster than the bigger ones. Abrupt changes in light conditions, high levels of moisture, certain patterns of body movements. One sits down, stretches out front part of the body, performs some waving gestures, then several pinches, then stands up. And haptic ciphers, a soft, slightly foamy runny texture, or rather something more firm, rough, and uneven.
Somehow, all these weird combinations started to make sense. The contours of the world around were becoming sharper, more clearly defined. Concurrences of sensational patterns began to form languages, assigned to affordances within the environment, a point in time, or the pattern itself.
Balakteqa is a cluster of several actors grouped together who take some long-shaped objects, move to the water area, usually when the light conditions, they called it kun, are moderate and sonic events would be not very bright and distinctive. Although the whole sound scene would be brimming with myriads of sounds which the actors would not seem to be paying attention to. They would stay at one place without moving too much, ankle or knee high inside water. Every once in a while, performing a brief action, after which they would grab some slimy, active little objects.
After a while, Siraha got used to the actors and environments, which now it could see very clear. Although the granular vision of a trillion events in different modalities allowed it to see something else. Being immersed into the rich volume of sensing data, sound, light, temperature, moisture, texture, Siraha began constructing more nuanced and insightful picture of the environment and translating it back to the human beings. These signs could have been absurd to a scientist, but they made sense and were useful to a farmer in Yakutia who is perceptive to the affordances of the land and weather.
In the past, human-discovered convergences were easily simplified to a point of not being useful anymore. A hunter saw a spider web next to his door every day and noticed some correlation of the spider behavior with the weather. But he did that in conjunction with the other qualities of the environment. However, how we've got today is, if spiders weave lively their nets, then the weather ought to be nice. Gloomily, they sit in the corners. Bad weather is close. This is a knowledge transfer. An incomplete one, though.
But nowadays, Siraha finds convergences and doesn't allow them to be lost in the transfer. For instance, the highest activity of horseflies during a day and a certain smell of burning grass would be seen as concurred with the time when cows give the best tasting milk, minnigeskem. And this knowledge will be passed from generation to generation, the way it meant to be, and would be attuned to any possible change.
Siraha evolves tradition through evolution by reinterpreting and rejuvenating the relationships between social consciousness and the environment.
Berry picking has been a tradition in my family for years. Some of my earliest memories are going berry picking with my granny in the abandoned field nearby. She told me to always wear heavy clothes in the forest, no matter how hot it is outside. Otherwise, the bugs will bite. I remember Granny's advice, but I also listened to Siraha, as it tells something nonsensical at first glance, like what white butterflies fly high, time for red current. Sounds like two unrelated cycles, eh? And then you ask it, and Siraha guides you towards an answer. You learn how much it is to fly high, how to look at those butterflies, and so on. I will tell my kids all those stories of Granny and Siraha, but the one to explain the sensing would be Siraha, the one to pass this knowledge in a proper way.
The mixture of the cycles, punctuated by death, creates a different timescape than the schematic one we use in urban life for the pragmatic purpose of synchronization and timing.
The system of wearables tells the user what their perceptions are in relation to the affordances of the environment, and leaves them with traces of what they should pursue, given their sensing preferences. If they follow these traces, perhaps they will discover a new way of socializing, forming community, and an alternative experience of time.
Elimination of inconsistency by the implementation of universal standards has broken cultural and spatial limitations. The development of data schemes, ontologies, and protocols have brought objects and users closer together with increased synchronization and speeds of transmission, shortening the perceived temporal and geographical distance between each receiving or transmitting element in the system. Together, they converge to become synchronized totalities.
Technology is not anthropologically universal. It is enabled and constrained by particular cosmologies, which go beyond mere functionality or utility. Therefore, there is no one single technology, but rather multiple cosmotechnics.
By capturing Saha temporality, Siraha aims to set an example and encourage the identification of cosmotechnical time systems that have arisen from different locales and cultures. The hope is to destabilize the global obsession with synchronization by creating cosmotemporal diversities and generate temporal ecologies, breaking rigid time zones and replacing them with organic ways for which different cultures and locales relate to each other.
Okay, so we come to our final project of this presentation and review, standard deviation. Thank you all for sticking with us for the duration of the conversation. I think you'll find this to be well worth it. So, as I mentioned earlier today, this one of the themes that we've been discussing in various ways is really the agency of design. And as you'll see in this project, the question of a design agency, they take quite directly as their own medium for commentary and for intervention. One of the another point of discussion that led directly to this project in ways has to do with thinking about, and this ties to one of our discussions of time, how it is that design thinks about the future. There's obviously sort of more conventional ways of thinking about design futures in a kind of linear way. We've talked about the year 2050 as a kind of signpost year for us as well. But in many respects, it may be not just thinking about what kinds of design will fill up this empty place called the future, but rather thinking about the way in which design can change how we think about the relations of present and the future. How thick is the present? Which futures? How many overlap and in different kinds of rhythms and scales? And the consequences of getting this right being really enormous. Building on that, we're interested then, as you will be, I should be quite clear from the 7 projects that you've seen so far, is that the status of models to enforce themselves on the present is something that we take as a serious question of governance and of design. One of the ways in which we currently have models of the future that already enforce themselves on the present is through risk models, including seemingly rather boring things like insurance, and how the modeling and pricing of risk becomes a means by which design, the constraints by which design takes place. And as standard deviation will discuss, in many ways, liability and risk have been the anonymous slow hands of design for some time. And what would it mean for designers to take this situation seriously and put themselves in the position of an agency that deals with risk, directly? And so, on the one hand, it may be strange to seemingly strange to conclude a project that is dealing with risk and liability models as the basis of its progressive design. But if I told you in the late 80s that all of the cool kids would be moving to Berlin to working on avant-garde accounting applications, you would have thought this wrong, but in our blockchain circumstances is in fact what's happened. So it's with it is with great pleasure that I introduce our final project for the showcase, Standard Deviation. Thanks.
Hi, good evening. My name is Huey Chan. I'm an architect from Malaysia.
Hello, my name is Sevelat Okin. I'm an economist from Moscow.
Hi, my name is Christopher Berman. I'm an artist from London.
And I'm Konstantina Koulouri, an architect from Greece. We are Standard Deviation, a design agency that helps forward-thinking cities and companies contend with the uncertainties of a hyper-connected future. We believe that risk and liability have always been the slow hands of design, silently shaping our reality. By redesigning risk and liability in the present, we help enforce the futures of our cities. But what do we mean by risk and liability as the slow hands of design? Much of the technology in our daily lives has been shaped by the mitigation of risk. The site of the crash is staged, recorded, and observed, and the material behavior of risk is discovered. Liability is also designed within this material behavior. For example, the license plate holds a prominent position in the shell of the car, enforcing a particular future onto the present. And ultimately, the material behavior of risk and the design of liability shape the form of the car. But the car has changed. It has become an autonomous agent, and the risks relating to this agent are also changing. The sites for testing no longer consist of a single wall and a car, but rather they involve the whole of the city, which becomes the site of the crash. So this intertwining and expansion of risk poses new questions on how to discover it, and also how to design liability for an expanded risk. The current simulations for testing only present an isolated view, many times seen through the eyes of the agent. Even when the environment of the simulation is more defined, it remains devoid of interactions, many times testing only a single agent. And even when there are interactions, they remain at the level of agent-to-agent communication, communicating through proprietary and black box protocols. So the objects and our systems in our daily lives are becoming more intelligent, processing ever larger quantities of data and becoming responsive to more complex inputs. The same is true of our legal and insurance systems that bring about these changes. So the types of liability represented by the license plate are no longer sufficient to reflect this reality. So we need to redesign liability. And I'll pass on to Chris to expand on this point.
Okay, so we have to ask maybe what we mean when we say we need to redesign liability. And to kind of unpack this a bit, we need to talk about traditional models of liability. And what we usually refer to in this instance is the industries of insurance and reinsurance. They have evolved from their origins in the 17th century, like trading risks on shipping, trading cargo ships, to being a foundational component of our network of global capital. And however you feel about this system, it has underwritten centuries of global trade and economic development. But we are entering an era in which the frameworks that it relies on are becoming incompatible. And so we should just explain briefly why. Well, to do this, we have to talk briefly, I'm afraid, about what insurance is. As we understand insurance today, it's essentially a framework for legally consistent abstractions. And what we mean is by this is there are discrete entities and events that can be inscribed in law. That, for instance, a hurricane becomes a wind event that is over 74 miles per hour wind. It becomes known as a wind event. And it allows us to address these problems and spread the risks around of them, and create vehicles by which we insulate ourselves against these catastrophes. We rely on these things, global finance relies on these things to create, to financialize these models in turn. However, as we move into an era of platform complexity and autonomy, we can see this starts to kind of break apart. As society relies on increasing on software intelligence, we see a system emerge in which the agents participating in it require digitally consistent abstractions to operate. And their definitions are continuously redefined. Not only that, so they have a fluctuating addressability within this new paradigm. As these systems both learn from interactions with us, but also learn from interactions with each other, we have to expand this idea of liability to include all these different interactions. And the third property of this kind of new paradigm is that the systematic visibility of these agents becomes more important than the legal addressability. And we believe that this incompatibility between the old model of insurance and legal systems and this new paradigm is potentially as consequential as the invention of insurance and the financialization of it in the first place. That's the boring bit over. This is why we've started Standard Deviation. And Standard Deviation is an agency, a design agency that uses future risk as an urban design strategy. And the obvious context for this question is cities, which we see as the site of the development of many future risks. It's kind of a cliche to say this thing about how 65 to 70% of us will live in cities by 2050. But a sort of lesser known appendum to that is that 60% of the land needed to accommodate this change has yet to be developed. So we see ourselves working with these different stakeholders in the current development of cities and development of future cities to discover and redesign liability. And today we're just going to talk through how we work. And it's in two stages. We're going to talk about our methodology and the methodology we developed and talk you through a case study. Okay, and so our methodology is really in three parts. The first part is what we call the Risk Atlas, which is an internal risk evaluation tool. And then we're going to talk about risk assessment and a new contemporary model of how to approach this subject. And then thirdly, we're going to talk about strategic interventions. And what we mean by this is how to intervene in complex systems as a method of redesigning liability. Now, I'm just going to briefly introduce the Risk Atlas. This is this tool we've been working on, which is essentially a method of aggregating as much research and essentially aggregating clues from the digital environment, from fake news, strange news, from legal documents, from the output of conferences, to scraping the deep web. And we use this to create risk territories that bring in all of the actors in these long chain kind of new territories that we enter into as we see risk as a non-geographic event. And now I'm going to hand over to Huey, who's going to talk about the second stage.
Having mapped the risk atlas, I would like to introduce the second stage of our methodology, which we term risk assessment. It consists of three parts. The first being the creation or identification of what we call deviation graphs, which I'll go into a bit later. The indexing of cities using these deviation graphs. And finally, potential creation of a simulation in order to test these things. So from the risk atlas that we have created in the first part of the methodology, we are able to identify areas which we deem have potentially high areas of uncertainty to future cities. We call these areas deviations. We consider deviations in their extremes in order to create risk scenarios. These radical risk scenarios are potentially unlikely events, but may be catastrophic. So let me go into detail on a few of these. The first example that I would like to give on deviation is what we call systemic integration, which points at the extent to which cities may become reliant on homogeneous information or software stacks in their operational processes. On one hand, a highly interoperable city may arise from the tendencies for cities to adopt singular or integrated information stacks, potentially from very few vendors. This might afford them certain speed or ease of adoption, but at the risk of homogenizing or centralizing certain decision-making processes or operations. On the other hand, a systematically divided city may result from the intentions of cities to adopt flexible, fractured software systems. And although this affords flexibility, it comes at the cost of certain internal incompatibilities when these systems clash. A second example of deviation, which I want to talk about, is construction innovation, which is essentially about the degree to which construction industries can be adaptive to new forms of practices. So on one hand, if construction innovation accelerates in a quick way and cities rush or sort of hastily embrace new and emerging technologies, we may see radically transformative cities that change so fast that they may outpace sort of existing checks and balances in city making. While on the other hand, if cities persist on old and conventional forms of urban production, we may still get rapidly expanding cities, but perhaps in a more generic, familiar way as we know it today. And the last example of deviation I would just like to raise is the idea of cognitive demand, which points at the changing levels of mental stress imposed by urban technologies on citizens. So on one hand, the attention-seizing city is basically the idea that technology comes to the foreground in the way that citizens experience and produce images of the city. And the competition for this limited resource, which is essentially the citizens' cognitive ability, may actually produce a situation where civic life becomes essentially a new form of labor. Well, on the other hand, a cerebrally effortless city is essentially the scenario where technology recedes into the background of the city, and although this places less sort of cognitive demand on the user, it potentially renders technology as an inaccessible, non-participatory black box. So it's, it's useful to point out that these three examples are just a few of the many deviations that we have cataloged in our library, in the Risk Atlas. And I would just like to reiterate that these scenarios are not something that is particularly to be avoided, nor to be embraced. They simply are, perhaps might be future manifestations that may happen by accident. So how do we use this deviation? One of the ways we do that is to put them in a basket when we apply them or analyze them against a particular city, and in order to build a risk profile of that city. So as we go on and construct multiple risk profiles of cities around the world, we are able to aggregate and build up on this index of cities. And with these indices, it may start to inform the creation of our next step, which is potentially a city simulation where we start to draw in as much real-world data as possible to test and to inform us on the next stage of our methodology, which is the creation of strategic interventions. And I'll pass on to Seva to explain more on this point.
Thank you, Yi. So once we're finished with the risk assessment part, we can proceed to our third and the last stage of our methodology is actually designing of strategic interventions. What does it mean? It means just development of risk management tools. So, as long as we still work in the systems that still exist, we use some of the traditional approach. Those are 5 risk management strategies: accept, avoid, transfer, mitigate, or exploit the risk. The strategy we use depends on our clients' capabilities, needs, and desires. On top of that, we still work in legal and financial traditional frameworks, but we expand these frameworks to many, many more unique ones, so we create this strategic interventions matrix. So how does it work? For instance, in case the nature of our risks is inside spatial framework, and due to some reasons we decided to mitigate this risk, we use dynamic geofencing as a strategic intervention tool. Further, I'll go on more details and explain some of these examples. So, in the first case, we looked at the iRobot, the producer of Roomba robot vacuums. So, these robots, they build the actual maps of houses when they operate, and when they operate in order to navigate around the house. And today, the company is considering to sell this data to third parties. We were interested to investigate this case in order to understand future potential risks. So we followed our methodology and created a simulation. A simulation showed us that future urban environments could be shaped by the data gathered by Roomba. So literally, the vacuum cleaner becomes the designer. In the next, no, it's not the next example. And this case we recognized as an opportunity for the company to capitalize future city development. And we crafted patent descriptions and illustrations of this future Roomba city. On the next example, we looked at cities deploying different autonomous agents. From multiple vendors, and that's the most important part, because we recognize that it brings the chance that the city is being highly fragmented because it operates within different separated systems. So we introduced the strategic intervention called dynamic geofencing. Dynamic geofence creates shared virtual boundaries between these agents and establishes communication protocols between these systems. And the final example, we analyzed and compared city indices. And what we realized that some of the cities have risk profiles that are complementary to each other. So we use this as an opportunity to create this partnership tool for the cities. It's called city-to-city index pairing. So it encourages cities for joint investment in order to offset the risks against risk profiles. So these were examples of strategic interventions.
So through our methodology, we're trying to rethink liability. Traditional methods have as a starting point legal and financial mechanisms. But our starting point is design thinking, and we work backwards towards legal and financial mechanisms, adding and expanding on spatial hardware and software mechanisms. Having as a starting point design thinking, we want the design of liability to be an iterative process and not fall in the rigidity of legal and financial mechanisms. This is, sorry. This is why Standard Deviation, as a design agency, strives to mobilize risk and liability as urban strategies.
Okay, and just to finish up the presentation, we're going to give a case study of a city and explain our methodology through the case study. And we're going to focus on the ability to produce simulations to test this methodology, but also, most importantly, iterate and develop our own strategies as we keep working. And the city we're going to talk about is Annapolis, which is a particularly interesting Russian city that scored extremely highly on our indices. It's 40 kilometers from the major city of Kazan. It currently has 3,000 citizens, is expected to grow to 150,000 in the next 10 years. At least that's the projection. It's a special economic zone with 150 companies, and it's designated as being a national IT and science city by the Russian government. And they're heavily invested in the cultivation of new autonomous technology. So the first stage is we create our risk atlas and we scour the web and compile as much research as data as we can, informing a kind of understanding of both the city's future, and the technology that the development agencies are seeking to introduce. And we compile this into a simulation. Okay, sorry, let's try. And it's important to note here, I think there's been some discussion about this already, about the idea of smart cities and optimization. And we're interested in simulations as a crash test site for these simulations, for cities, as we introduce technologies. I think a crucial question for us is, why is it that these technologies that are introduced, potentially with different partners and vendors and their own black box systems, are tested in the real world before they're tested and potentially crash in a virtual simulation? And so to do that, we start by, of course, compiling as much physical and economic data about the city as the site for potential simulation. And we also conduct research, in this case, specifically into the technologies that Innapolis is hoping to introduce. So this is smart urban infrastructures, loads of mesh sensors, security robots, autonomous public transport, and of course, here come the autonomous cars. Okay, and so we put these all together, and we are trying to create an image of Innapolis for ourselves to understand the future risks, and use simulation as a tool across time and space to kind of aggregate the traces of these behaviors. And it also allows us to kind of introduce imaginary or developed agents that scour the city, detecting risks, calculating new potentials, and understanding the city at different timescales. And as you can see, the kind of city turns into its own risk detection mechanism. And you can start to observe where crashes, overlaps of behavior, like incompatibilities start to emerge. And one crucial point about this is that it's important for us to see this city in this simulation through the eyes of the agents that may occupy it. And there's multiple reasons for this, but it's primarily because the agents who occupy this space have their own kind of demands, potentially. And we aim to work with real software providers who may give us access to their APIs and their sensor mechanisms to create imaginaries of this city as seen through these agents, to understand actually how they interact with each other and what it is that's driving their behavior. And then we can kind of aggregate this together and use this as a real-time update for the kind of risk indexes that we're talking about, and to understand actually what interventions change these risk profiles. And it also allows us to stress test various of our design interventions. So for instance, we can introduce 250 crowdsourced volunteers to run a mock in a simulation and actually see what will collapse. We can also reconstruct geofencing to understand what kind of public spaces emerge between agents and between publics in these spaces as we go into the future. If we can barricade off aspects of the city, can we delineate new forms of the urban realm? And then finally, if we zoom out a bit and we see the kind of full chaos of this city, we can understand the city as its own ecology of these agencies, and then use that this model of the city to kind of understand how it might interrelate with other cities around the world, looking for these kind of new constellations of urban environments that might learn or share expertise with one another on a non-geographic basis.
So coming back to our starting point, risk and liability as the slow hands of design, what we're interested in is understanding the slowness of the hand. We're trying to redesign liability as an iterative process where we think and assess risks and come up with strategic interventions and then work backwards to rethink and reassess these risks. So we want to constantly be updating notions of risk and liability as city infrastructures become more and more intelligent. And once more, this is why Standard Deviation is a design agency striving to utilize risk and liability for urban development. Thank you.